So let me ask you straight up, because this is the real test, isn't it? If I dropped you in front of some random piece of equipment, could you, in 60 seconds, tell me which code, which rules, which risk category applies? It's tough, for sure, but getting that answer right and getting it fast is exactly what we're going to nail down today.
And let's be real, the stakes are huge. Getting this classification wrong isn't just a little oopsie on a spreadsheet. We're talking about choosing the completely wrong path for compliance. That means project delays, money just burned on rework, and the absolute worst-case scenario, your equipment gets rejected at the very end. This is about safety, your budget, and your schedule, all riding on getting this right.
But hey, don't sweat it. We're going to cut right through all that complexity. Together, we are going to build a super simple but really powerful 5-question mental toolkit. Think of it as a little checklist you can carry around in your back pocket to use on any piece of gear, anywhere, and get the right answer every single time.
So this is it, your 5-question mental toolkit. It's the framework we're going to use. And look, the whole point here isn't for you to memorize endless, boring tables from a code book. No way. It's about learning how to think your way through the problem like a seasoned pro.
And here is our roadmap. Just 5 straightforward questions. Number 1, what is it? 2, what's inside of it? 3, what are the numbers? Pressure, volume, that kind of thing. 4, how dangerous is this thing really? And finally, the big one, number 5, who has to sign off on it? That's the proof. Let's break them all down.
Okay, first up, decoding the PED risk grid. We're going to use the European Pressure Equipment Directive as our example to tackle our first 4 questions. All right, question 1. What is it? Now, I know, it sounds almost too simple, right? But you have to start right here. Are we even looking at pressure equipment? We're talking about any closed container that's holding a fluid, a gas, a liquid, whatever, at a pressure higher than the air around it. If the answer is yes, we're in business.
So, what kind of stuff are we talking about? Well, you've got the obvious things, right? Vessels and piping, check. And safety accessories, like relief valves. Yep, those too. But the really interesting stuff, the things that trip people up, are the borderline cases. I'm talking about filters, the heating jackets on a vessel, or even tiny little accumulators. You have to be a detective and ask this question for everything.
Okay, so we've identified our target. Now we move on to questions 2 and 3. What does it hold, and what are the numbers? This is the investigation phase. First, what's the fluid inside? Second, what are the specs? You need to hunt down that design pressure, the PS, the volume, or V, and for piping, the nominal size, or DN. Time to start digging through the drawings or staring at that nameplate. Now, when it comes to the PDE, the fluid inside is a huge deal. They basically sort everything into 2 simple buckets. Group 1 is all the dangerous stuff. Things that can go boom, catch fire, or are just plain toxic. Group 2 is, well, pretty much everything else. Water, steam, nitrogen, the usual suspects. And here's the key. The second you see a Group 1 fluid, you know the hazard level just shot way up.
And here we are, the moment of truth. Question 4. How dangerous is it? This is where we put all the puzzle pieces together, the numbers we found, the fluid we identified, to get the final verdict on the overall risk.
And honestly, the logic here is beautifully simple. Just think about it. Pressure times volume. That's basically a measure of the stored energy. It's like a giant compressed spring. The more energy it's holding, the bigger the potential problem. Now, what happens when you combine all that high energy with a dangerous Group 1 fluid? Bam! You are in a much, much higher risk category. It really is that straightforward.
This shows you the whole ladder of risk perfectly. At the very bottom, the lowest risk stuff is called sound engineering practice, or SEP. But as that stored energy and fluid danger start to go up, you start climbing the ladder, up to category I, then I, 3, and all the way to the top at category 4. And the higher you climb, the stricter the rules get, and the more likely you'll need a third-party inspector, a notified body, looking over your shoulder.
Okay, let's switch gears and talk about the ASME mindset. If you're based in the US, this is your world. And listen, don't get thrown by all the different terminology. It might seem like a totally different planet, but the fundamental thinking is exactly the same. It's the same goal, just spoken in a different language.
So let's just put them right next to each other. In Europe, the PED uses that risk-based category system we just talked about. Categories I through IV, and your goal is to get a CE mark. In the US, the ASME code is organized more by the service of the equipment. So you pick a specific code section like section 8-1 for a vessel or B31.3 for piping. And the prize at the end is a certification mark, like the U stamp.
But here is the absolute most important thing to get. A CE mark, a U stamp, it doesn't matter what it's called. They're different stamps from different systems, but they represent the exact same core principle. We are controlling the risk of a catastrophic failure. That's it. That is the whole ballgame.
And that brings us to our final question. This is the one that really locks in your logic. Question 5. Who must sign off? And I'm telling you, this is the step that separates the amateurs from the pros. Because it's not enough to just know the answer in your head. You have to be able to prove how you got there.
Let me be crystal clear about this. When a notified body, an inspector or an auditor walks in to review your project, the very first thing they are going to ask for is your justification. Show me why you chose this code and this category. A clear, logical note makes their job easy, and more importantly, it builds instant trust in you and your work.
So, what does a great justification note look like? Think of it like a recipe. You list your ingredients, any assumptions you had to make, your key numbers, pressure, volume, nominal size. You clearly identify the fluid and what group it's in. Then you state your conclusion, the resulting category or code section. And, this is critical, you cite your source. Point them directly to the table or clause in the code that proves you're right.
All right, we have covered all the bases. We've built the toolkit, we've seen how it works for PED and ASME, and we know how to document our logic. Now it's time to put it all together so you can take this out into the real world.
Let's run through it one last time. Rapid fire. 1. What is it? Vessel, pipe, you name it. 2. What's it hold? Group 1 or 2 fluid. 3. Give me the numbers PS, V, DN. 4. How dangerous is it? Find that category or section. And 5. The final step, prove it. Document everything clearly. That's the framework.
So you think you've got it? Here is my challenge to you. Pause right here, take a screenshot of this checklist. And the next time you walk past a piece of equipment on your site, I want you to stop and run through these 5 questions. See if you can classify it in under 60 seconds. This is how you turn this knowledge into a real skill. Go on, test yourself.